Good afternoon, class. We are looking at chapter 11, sequences and series. Here's 11.3, geometric sequences and series. So we've looked at sequences and series, arithmetic sequences and series, and now geometric sequences and series. The objectives are: find the common ratio for a geometric sequence, list the terms of a geometric sequence, use a recursive formula for a geometric sequence, use an explicit formula for a geometric sequence. Recall, S sub n is the sum of a sub 1 all the way to a sub n of the first n terms of the sequence. This is sigma, is the Greek letter sigma and indicates a sum. The sigma notation, summation of I going from 1 to n a sub I, means add the terms a sub I beginning with the first term and ending with the nth term. I is called the index of summation. A finite series, S sub n equals a sub 1 plus a sub 2 all the way to a sub n, summation of I going from 1 to n a sub I. An infinite series is basically the same thing, but we never stop. Summation of I going from 1 to infinity a sub I. Summation properties, if a sub 1, a sub 2, all the way to a sub n, and b sub 1 all the way to b sub n are two sequences, and c is a constant, then for every positive integer n, summation of c is nc, as I goes from 1 to n. Summation of c is c, you can take the c out, times the summation of a sub I. Number 3 says that the sum and differences can be separated. Summation of I is n times n plus 1 over 2. Summation of I squared is n times n plus 1 over 2 n plus 1. And summation of I cubed is n squared times n plus 1 quantity squared over 4. Arithmetic sequence and series. An arithmetic sequence, each term after the first one is found by adding a fixed number called the common difference. Sometimes they call it a distance. To the previous term is an arithmetic sequence or arithmetic progression. A sub 1, the next one is a sub 1 plus d, the next one is a sub 1 plus 2d, and so on. The difference d between consecutive terms is constant, and the sequence can be defined by either recursively a sub n plus 1 is a sub n plus d, or explicitly by a sub n equals a sub 1 plus n minus 1 times d. For example, 1, 5, 9, 13, we can see we are adding 4. 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17, and so on. The nth term is given by a sub n equals a sub 1 plus n minus 1 times d. The sum of the first n terms, s sub n is n over 2 times a sub 1 plus a sub n, if the n term is given. If not, we use this one, n over 2 times 2a1 plus n minus 1 times, if we use this one here, we get to this one, and this is the synopsis of what has been discussed. And now 11.3, geometric sequences and series. A geometric sequence or geometric progression is a sequence in which each term after the first is obtained by multiplying the preceding term by a constant non-zero real number called the common ratio. Geometric sequence, a sub 1, a sub 1 times r, a sub 1 times r squared, and it continues, where each term is r times the previous one, can be defined recursively by a sub n plus 1 is r times a sub n, meaning if you want a term, pick the previous one multiplied by r, or explicitly a sub n is a sub 1 times r to the power of n minus 1 in general. Example, 1, 4, 16, 64. Notice 1 times 4 is 4. 4 times 4 is 16, 4 times 16 is 64, 4 times 64 is 256, and so on. Sum of the first n terms of a geometric sequence, S sub n is a sub 1 times 1 minus r to the power of n over 1 minus r. R can't be 1, and here's the synopsis of everything that has been mentioned here. All right, let's look at the following proof. A geometric series is the sum of the terms of a geometric sequence. That's by definition. And so if you have a plus ar squared, it's written as summation of n equals 1, ar to the power of n minus 1. And of course, a can't be 0. So S sub n can be written as a plus ar squared all the way to a r to the power of n minus 1. Let's multiply both sides by r. So what happens? We get r times s sub n. This one becomes ar. This one becomes ar squared, ar cubed. This one becomes ar to the power of n minus 1, and this one becomes ar to the power of n. So you're multiplying everything by r. Let's subtract. If we subtract this from this, notice this one minus this one. So everything cancels out. A sub r, remember, they are going to have a negative sign in front of each one, right? So if I put minus a sub r cancels out, ar squared cancels out, and all of them cancel out, this remains a minus a r to the power of n. I hope you see that. Very straightforward. I can factor out s sub n from the left side. I can factor out the a from the right side. And so if I divide by 1 minus r, that's the proof that S sub n is a times 1 minus r to the power of n over 1 minus r, sum of the first n terms of a geometric sequence. So S sub n, summation of I going from 1 to infinity is ar to the power of n minus 1, a plus ar squared, and it continues indefinitely. So what is that equal to? That is equal to the limit of this as n goes to infinity, everybody. This is, in essence, a topic getting to the next course. So this is S sub n when we stop at n. This is S sub n when we continue until infinity. So we can say the same thing, but we take a limit as n goes to infinity. If r is between negative 1 and 1, r to the power of n goes to 0 as n goes to infinity. Just to show that with some basic numbers class. For example, let's say I'm making this up. Let's say r is 1/2. If I square that, I get 1/4. If I cube that, I get 1 over 8, and so on. So what's happening? This is larger than this one. This is larger than this one. As I add to the exponent, I make this smaller and smaller. So eventually, when n goes to infinity, this becomes so small, goes to 0. That's exactly what we are saying. Therefore, if this goes to 0, you just get a times 1 in the numerator. So if r is between negative 1 and 1, the infinite sum, the geometric series, converges. So that's the way it works out. If r is between negative 1 and 1. So it's pretty straightforward, everybody. Let's move on. Show that the sequence is geometric, list the first term and common ratio. If you claim something is arithmetic or geometric, first you have to come up with the first term, then you have to come up for the arithmetic, the d, the value of d, the distance or the difference. For geometric, you got to come up with the common ratio r. So obviously the first term is 2. Now divide 8 by 2. That gives you 4. In other words, if you multiply 2 by 4, you get 8. Now check. 8 times 4, do we get 32? Yes. 32 times 4, do we get 128? Yes. Which has proved A1 is 2, R is 4. So we showed, and again, you have to check it. I can't emphasize this enough, everybody. How about here? S sub n is 3 to the power of n plus 1. Let's write it. Let's choose n to be 1. The first one is 9. Let's n to be 2. And just continue. 9, 27, 81, and so forth. So clearly, we can see that A is 9. R must be 3. How do we know that? (27) divided by 9 is 3. So 3 times 9 is 27. 3 times 27 is 81, and so forth. In fact, A sub 1 R to the power of n minus 1, the base represents the R. Okay, now choose n to be 1, 2, 3, see what you get. So we are going to go with n equals 1. That gives you 3, 2 to the power of 1, which is 6. N equals 2. 3 times 2 squared, 4 times, that is 12, and 24, and so forth. So clearly, this is being multiplied by 2. So the first one is 6, and R is 2. Or just, as I mentioned, look at the base here. So it becomes clear what we are dealing with. But one easy way, just work it out. So, and the way you work it out, it's simple. Just divide the second term by the first term, the third term by the second one, and so forth. You really have to check it, okay? So, and sometimes just to be on the safe side, more than 3 terms, you go with 4 or 5 terms and so on. Find A sub n and A sub 5 for this geometric sequence. The moment you have a geometric sequence, you have to come up with 2 things. The first term obviously is 4. And R, divide this one by this one. You get -3. So see if it works with the rest of them. In other words, this one times -3 must be 36. This one times -3 must be -108, and so forth. So whenever you come up with R, check. Now we want to find A sub n and A sub 5. A sub n has this formula, everybody. So we plug in. A sub 1 is 4, R is -3 to the power of n minus 1. You want a sub 5, replace the n with 5. Makes it 4 minus 3 to the power of 4 is 81. Okay. Find its recursive formula. By recursive, we mean this. A sub n plus 1 is R a sub n. And R, we found it to be negative 3. So let me erase my word. A sub n plus 1 is R negative 3 times a sub n. Which means if you want a term, pick the previous one multiplied by negative 3. That's exactly what it says here. We want to find the summation of I going from 1 to 6. Understand concept of a summation. It means the following, everybody. It means just say 2 times 3 to the power of 1 plus 2 times 3 squared and all the way 2 times 3 to the power. That's the meaning of it. You can do it one by one. You may notice this is geometric series because it's 6, 18, and 54. All you have to do just plug in 1. So let me just go. If I plug in 1, I get 2 times 3 to the power of 1, which is 6. If I plug in 2, 2 times 3 squared, which is 2 times 9, 18. If I plug in 3, 2 times 3 cubed, 2 times 27 is 54. And we can clearly see that from here to here, we are multiplying, a sub 1, of course, is 6, and we are multiplying by 3. And so we have a geometric series with a sub 1 being 2 times 3 to the power of 1 equals 6, and R being 3. So therefore, we are going to use the formula that we have here. And let me erase my one. So that's the formula, and we want a sub 6. Okay, so that means a sub 1, which is 6, 1 minus R, which is 3 to the power of 6, 1 minus 3. So that's the meaning of it. So you put it into the calculator or you calculate it yourself. These two cancel each other. They give us negative 3. This is minus 728. The product is positive 21. Sometimes they write it in this fashion. Sometimes they write it in this fashion. Lower limit, upper limit. Okay, what about this one? We are looking at basically the same situation. And the difference is that this continues indefinitely to infinity. So let's write the first few if we put I equals 1, we get 3 over 5. I equals 2, we get 3 over 5 squared, which is 9 over 25. If you put 3, you get 27 over 125. And that clearly tells us that we are dealing with a geometric series. The first term is 3/5, and so is the R. Both of them are the same. So this is the formula, but when R is between -1 and 1, this is the formula. And that's what we are going to use because R is between -1 and 1, R is less than. So this summation to infinity is a sub 1 divided by 1 minus R. It's a complex fraction. We're going to multiply by 5 over 5. The numerator becomes 3. The denominator becomes 5 minus 3, or 3/2. Meaning, if you continue indefinitely, it converges to 3/2 and it stops. Converges means it has a solution. What about this example? We want to add these terms. First, we have to recognize what type of a series or sequences we are dealing with, because we are adding it's a series. Here's the first term. Notice if I multiply this by 1/2, I get 1/4. By 1/2, I get 1 over 8, and so forth. That means A and R are both 1/2. So we are going to use this formula because R is between -1 and 1. So the summation is A sub 1, which is 1/2 over 1 minus 1/2. You may recognize this as 1/2 over 1/2 is 1, or times 2 over 2, and it's 1. So think about it. 1/2, add half of it, 1/4, then add half of it, 1/8, add half of it. And if you keep on going forever, it ultimately reaches 1. Repeating decimals, express 0.46 bar as a 6 bar as a rational number. Another approach is to write these repeating decimals using geometric series. In algebra, we set this equal to x. I'm going to set it. I'm going to get that going for you. Finish it at home. This is what you should have seen before. They should have taught you that you let x be 0.46 bar. And because it has 2 decimals, you're going to let x, not x bar. And then they multiplied by 100, and they get 46.46 bar. Then they subtract one from the next one, calculate the x. This is what you have seen. How do we do that here? First, this is the meaning of it, 0.46, and repeat it. Now this is 46 over 100, or 0.46. This is 46 over 100 squared, or 10,000, or 0.0046, and so forth. So you can write it in a fractional format or a decimal format. Needless to say, the first term in any format is 0.46 or 46 over 100. And R, notice, this is important to realize, this is 100 times larger than this. That means the fraction is 100 times smaller. So R is 1 over 100 or 0.01. Because R is between -1 and 1, we're going to use this formula. You could use the decimals instead of that. Either way makes no difference. And I'll show you both ways. First, let me erase my work. If you go this route, you multiply the top and the bottom by 100. And again, you don't have to simplify this. I just want you to see the process. The product of these two is 46. The product of these two is 100 minus 1, 46 over 99. If you go with the decimals, is 0.46 over 1 minus 0.01, 0.99, and convince yourself they're the same. A population of fruit flies is growing in such a way that each generation is 2.5 times as large as the last. Suppose that there were 1,000 insects in the first generation. How many would there be in the fifth one? What is the total population after the fifth one? So I hope you recognize this as a geometric sequence with R being 2.5 and A1 being 1,000 insects. Why is it geometric? Because it's being multiplied by 2.5. For example, if the first is 1,000, the second is the product of these two, which is 2,500. So A sub n is A sub 1, or to the power of n minus 1, and we want the fifth one, so we want A sub 5. Which is A sub 1 or to the power of 4. So just plug in. A sub 1 is 1,000 or 2.5 to the power of 4. At this point, you have to put it into a calculator. And because you're talking about the number of flies, you have to answer with a whole number. So 2 next to it is 5, goes up to 3. What about the total population after the fifth one? Then they are asking for this formula, S sub n. So we want S sub 5. So replace the S sub 1 with 1,000 or with 2.5. And so put it into, it's 2.5 to the power of 5, subtract it from 1 times 1,000, divided by negative 1.5, results in this number. Again and again, we are dealing with number of flies. You have to round it 7. Next to it is 5, changes to 8. You have to round it because it's the number of flies. Okay, everybody? Find R and A1 for the geometric sequence with third term being 20, sixth term being 160. So first, what is given? A sub 3 is 20, A sub 6 is 160. So in essence, we are given 2 equations and 2 unknowns because A sub n is A sub 1 R to the power of n minus 1. So A sub 3 is A1 R squared is called 20. A sub 6 is A1 R to the power of 5, 160. So the 2 unknowns are A1 and R. When we have a case like this, the methodology of solving is just to divide one by the next one. So if I divide this one by this one, A6 divided by A3. A sub 1 cancels out A sub 1. This is R cubed, which is 160 over 20, or 8. R becomes 2. Now, all you have to do, pick one of those, go back to one of those, and for example, A sub 3 is A sub 1 R squared. It's 20, and we have R. So you know 2 squared is 4, divide by 4, and A sub 1 becomes 5. So that's how you arrive at the answer. It's very simple, everybody. So we have R as well as A sub 1. What about 5.75 bar? Let's also look at this one in the same manner by noticing that that's 5.75 and 75 repeats. So we are interested actually in finding this part because 5 is clear. So we can write it in 2 ways: fractional format, decimal format. And we are going to look at this part using the geometric sequence. This is the first term, A sub 1. This is 100 times larger than this. That means the fraction is 100 times smaller, or R is 1 over 100, or 0.01. Because R is between -1 and 1, we use this methodology. S sub n is A over 1 minus 1. So plug in 5 plus 0.75 bar is 5 plus, we are going to use this one, okay? So very straightforward. I'm going to multiply, or you can put a decimal. We can multiply by 100 over 100, in which case is to give us 75. As we said, this gives us 99, right? Because it's 100 minus 1. Or you can go with the decimal 0.75 divided by 0.99. Now this, the top and the bottom are divisible by 3, 25 over 33, and you're done. In some text, they may want an improper format. So 5 times 33 plus 25 is 190 over 33. Nevertheless, they are the same, and that's the final answer. Either way is acceptable as far as I'm concerned. How much will be earned on day tone if daily wages in cents follow the sequence 1, 2, 4, 8, 16, and so on? Well, What we are looking at is a geometric sequence because the first one is 1, A1 is 1, and R is 2, because 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, and so forth. And we want A sub 20. On day 20, we want A sub 20. So that follows A sub n equals A sub 1 R to the power of n minus 1. And A sub 20 is A sub 1 R to the power of 19, which makes it 1 times 2 to the power of 19. Cents. And so this is in cents. You put the decimal here, becomes in dollars. So I hope it's clear to everybody. So imagine 1 cent, double it, and in 20 days we get $5,242.88. That's the power of power, you know, when you raise it to a specific power. Exponential. It moves up exponentially. That's the idea. All right. How much will you have in all together after 20 days? That means S sub n, more specifically, S sub 20. And that means now we're going to use this formula. So plug in. A sub 1 is 1, 1 minus 2 to the power of 20 over 1 minus 20. So 2 to the power of 20 subtracted from 1 divided by negative 1. And you get this number in cents. And move the decimal here. You get $10,485.75. If they give us 1 cent only and then double it for 20 days, it adds up that fast to $10,485.75. An infinite geometric series. Again, find the formula for the general term A sub n of the sequence 1, negative 1/3, and so. That's the first term, and we notice if we multiply by negative 1/3, we get this one, by negative 1/3, we get this one, and so forth. So that means A1 is 1, R is negative 1/3, and therefore you're looking at a geometric sequence. And A sub n follows A sub 1, R to the power of n minus 1. Okay. What happens next? Plug in. We have A sub 1 as 1, R as negative 1/3 to the power of n minus 1. Now, normally when you have a negative sign, it alternates. For the alternating sign, they like to separate the two. So they may put the negative 1 out and say, okay, it's negative 1 either to the power of n or n minus 1 or n plus 1. N minus 1 and n plus 1 work the same way. Okay. So you check, and I'm going to explain about that alternating in a moment. You always check a sub 0 must be 1. If I plug in 0 here, okay, okay, do I get the 1? So if I plug in 1, 1 minus 1 gives me 0. Any number to the power of 0 is 1 times 1 is 1. Okay, same thing here, 1 times 1 is 1. So negative 1 to the power of n minus 1, 1/3 to the power of n minus 1, and we end up with 1. So you have to check. Now, for alternating sign, it's positive, negative, or vice versa, negative, positive, negative. Start with one of those. In this case, just in some text, they may use this will give you the same result as negative 1 to the power of n plus 1. Okay. The only thing is it may not work for the rest of it. It may not work for here. Okay, that's why you want to be careful. But these two result in the same thing. The first swing of the pendulum. So here's the pendulum, 25 centimeters and arc length. If each swing is 75% of the preceding swing, what is the length of the arc of the 11th swing? So this is the length of the arc. We get 25 centimeters for the first one. Then the next one is 75% that times that. And the next one is 75% of the second one. So you're clearly dealing with the geometric sequence such that a sub 1 is 25 centimeters and the R is 0.75. Why? Because it's 75% of the preceding. So what is the length of the 11th swing? We use a sub n equals a sub 1 r to the power of n minus 1, and we want a sub 11. Just plug in 25 times 0.75 to the power of 11 minus 1. You put it into a calculator, gives you 1.078. And you normally they give you how many decimals they want. If you stop here, you get 1.408 centimeters. If they don't give you that, you keep on going. You put many, many, many more decimals. So that would be for the 11th swing. How far or total distance does the pendulum travel after 15 swings? So it goes this much, comes back, back and forth, back and forth. They want to know the total size. Therefore, we're going to go with the S sub n. And n is 15, everybody. And we plug in. We just plug in and observe, which means 25 times 1 minus 0.75 to the power of 15. 1 minus 0.75, of course, this is 0.25. You do that one multiplied by 25, and you end up getting 98.664 centimeters. How far does the pendulum travel before coming to a rest, to stop? Now, because it's 0.75, what this is asking, what if it continues indefinitely until it stops? So you want this one, a sub 1 over 1 minus r. So 25 over 1 minus 0.75. This is 0.25. This ratio is 100. So it goes for 100 centimeters before it stops. Use a graphing utility to find the sum of the first 15 terms of the sequence 1/3 to the power of n. That is, find 1/3 plus 1 over 9 plus 1 over 27 all the way to 1/3 to the power of 15, which uses this formula, summation of I going from 1 to 15, 1/3 times 1/3 to the power of I minus 1. This can be J, you use J, this can be K, you use K. Anything, as long as the limit is constant, is fine. For a case like that, go to a calculator, go to the list by pressing second stat, write to math, press sum, get to list by pressing second stat, and so forth. So these are the ones that you are going to press. Okay, we get to math. Operations, sort, okay, express variable, start, okay. And so you put 1/3 is a sequence, okay. This number 5 is a sequence, everybody. So you put 1/3 to the power of x, the variable is x, start with 1, end with 15. The end is 15, everybody. It does the sum, and it gives you the answer. So there's not enough room here, but this sort of shows sum, the sequence 1/3 to the power of n and 1, comma 15, 1, in case that's the step, by the way. So that's if we want to use a calculator on that, just in case how it's used. It's mentioned here. Now use a graphing utility to find the following sum. This continues indefinitely. We use this one, S sub n, 1 minus r to the power of n over 1 minus r. You should recognize this one as a sub 1, and then 1 divided by 2 is 1/2, and so forth. I hope you recognize r as 1/2. Okay. You put it into a calculator. So creating a numerical table for a function, press y equals and enter the function to view the table. It explains how the TI is used, the windows, graphs. Okay. The second and graph uses the table. So you use the plot 2 times 1 minus 0.5 to the power of k and divide by 1 or minus 1/2. You can even say divide by 1/2, and it creates the table. And if you continue indefinitely, you end up with 4. If you want to do it by hand, you should recognize this one as 2 times 1 because this goes to 0, right? If you continue as n equals infinity, and this is 1/2, 2 divided by 1/2 is 4. So the bottom line is doing it by hand or otherwise makes no difference. It gives you the same answer.